Hello everyone, my name is Rajesh Kumar and I'm your DevOps, SRE, DevSecOps coach. I have close to 18 plus years of experience working in multiple MNCs around the globe and having in-depth knowledge of DevOps, SRE and DevSecOps. So I would like to introduce you one certification program in a DevOps, and that is we call it DevOps Certified Professional. Now this is a 2 months of program, 25 tools of DevOps you will learn, and apart from that you will also get the access to the LMS, lifetime access to the videos portal. It's a certification program, and you will have 25 assignments and 2 projects along with it. It's a completely weekend program, so here you have classes on Saturday and Sunday. So as part of this course, you will learn multiple things. Here you see that you will learn Linux, AWS, Docker, Jira, Confluence, Python, Git with GitHub, SonarQube, Maven, Gradle, Packer, Artifactory, Selenium, JMeter, Ansible, Kubernetes, Helm, Terraform, Jenkins, Datadog, Splunk, and Neuralink. Now, how do we, apply for this? So how can you reach out to us? So you have a WhatsApp number and email ID. So please reach out to us, and we'll help you to onboard this program. Apart from this DevOps certified professional programs, we are offering other certifications as well in a DevSecOps, SRE, and one of the very comprehensive programs which we have is in Master in DevOps Engineering. Yeah, so feel free to get in touch with us and then enroll for it. Thank you. Okay, so after that, learning the after setting up the cluster, now you have only one work, and that is to know what you want from Kubernetes. What is your desire? What you want from Kubernetes? So whatever you want, you declare in the YAML file or JSON file, YAML file and JSON file, and then you Kubernetes will give you. So the only thing which you need to learn is what you want. So here you declare in YAML or JSON, send it to API server, and then rest of the things will happen. So say you want 3 pod of Nginx. You declare in YAML or JSON, send it to API server. You got the 3 pod of Nginx. Let's say one node is down because of some reason. So your desire was 3, actually it's become 2. So third pod, now Kubernetes will create it. Automatically you don't have to do anything. And then desire is matching with actual, and then things done. So what you are going to learn? So basically you are going to learn in Kubernetes what you want to desire, because whatever you ask, you'll get it. So you want pod, you want controller, you want services, you want storage, whatever you want, you just have to set the desire. So many other resources also we have it. More than 60 resources you'll have it. So how do you know all the resources, all the features of Kubernetes? So simple, you just say qctl, enter. So many commands you have. So you are running this command from workstation, okay? So whatever the resources you have, just run this command API resources, and these are the resources, these are the features which is supported by API server at a Kubernetes. So your job is to learn all this stuff. So these are the resources, just like AWS also have so many resources. Same way, uh, same way you have a resources here also. So the first, let's say if you go to AWS, which resources you learn first? The first, very first resources which you learn, which one?
Virtual machine. EC2.
Virtual machine, EC2. So same way here you have a pod. That's the reason we are discussing pod. It's not like only pod is the resources. We have a more than 60 resources, 70 resources. AWS also have a thousands of resources, but you start with compute unit. So pod is also, you need to learn the first one at the Kubernetes platform. So let's understand the pod. What is a pod then? It's very simple. When you go to VirtualBox, VMware and all, what do you create? VM. When you go to AWS, what do you create? EC2 instance. When you go to the Docker, what do you create? Container. So same way, guys, when you come to Kubernetes, you create a pod. So pod is the atomic unit of scheduling. Now the VM, what you have? Operating system. Container, what you have? Root file system. If you remember the Docker session. Pod, what you have? Pod, you have a container. VM is running as long as the PID1 is running, systemd. Container is running as long as the PID1 is running. You know that. Pod is running as long as the container is running. All the containers are running, then pod is running. So what is pod? When you go to the Kubernetes, the first thing which you deploy is pod. Pod is the atomic unit of scheduling. Understanding? Are you understanding, all of you? So pod may have a containers, one containers, multiple containers. Here in Kubernetes, compared to the Docker, if you remember the Docker share all the network namespace, kernel namespaces and all. Here you get allocated to the pod. So whatever the containers you have, all these pods, all the containers share the same network, same namespaces and all stuff like that. That means pod get IP address, not a container in Kubernetes. Okay. So because if you have a two containers in a pod, both the containers you can access through the same pod IP address. This is called tight coupling. When you have two containers in a same pod, tight coupling. When you have one pod, one container, loose coupling. This right side, it's wrong. Left side is right. Why? Because in a pod, you should not deploy the similar container, because ultimately the pod we have IP address. So you'll not be able to use it all this container of Nginx. Different containers you can deploy. So you should try to deploy one pod, one container if it is a similar container. Okay, that's the right approach. So the first container which is running the pod, we call it a main container. Remaining containers which you are running is called, we call it sidecar container. Okay, so anything which got associated with the pod like network, IPC mount and all the containers can use it here. So pods are atomic, so you won't get a something same pod. So you get a similar pod. So let's say if you want to have multiple pod, you can get a similar pod. So here these are the life cycle of the pod: pending, running, succeeded and failed. If you remember that pod cannot be created, it can be instantiated. Create versus instantiate. Do a little bit of reading actually. So Docker container can be created, but pod cannot be created. Why? Because pod is a logical entity, not a physical entity. Container is a physical entity. If you ask me, Rajesh, can I go inside a pod? Not possible. Can you go inside a container of that particular pod? Possible. Okay. So pods, if you see that first image, container is not running, so pod is pending. Second image, container is running, so pod is running. Third, container either succeeded and failed, so pod also succeeded and failed. So these are the life cycle of the pod. First pending, then running, succeeded and failed. So pod, you have one container you can access through the IP address of the pod, 80 port. If you have two containers running, so you can use the IP address of the pod and container port number 80 and 5000 from outside. How this one pod talk to each other over the inside a cluster? So inside a cluster, they set up their own network that's called pod network. And each pod, irrespective of what node you are running, you are talking over the pod network actually, not a node network. Okay, pod network, inter-pod communications. If you want to access the pod from outside, you can use the IP address and the port number of the container. But if they want to talk to internally, you can use a local host for it. One container to another container inside the same pod, they can use a local host. So what is a pod? So pod is having one or more containers. It can be your application, it can be service. Service is like a load balancer in Kubernetes. The most basic unit of work in Kubernetes is pod. Most basic unit of scheduling in Kubernetes. Pods are ephemeral. No pods is ever redeploy. That means if you say, hey Rajesh, I want the same pod, not possible. If you say I want similar pod possible, that is called inferal. You cannot redeploy the same pod once it's gone. They are there or not. Simple. So what is the job of the Kubernetes? Job of the Kubernetes is to run your pod. More specifically, Kubernetes will help you to manage the pod state, health, and so on. So guys, did you understand that pod, all of you?
It is the same thing like what we discussed in the container, in the Docker, right? So once we create, you cannot, recreate it. You have to delete it and create the new one. It's the same
No,
concept.
container you can stop it and then start it. Pod you
Yeah.
cannot stop it and start it because that life cycle is not there. Pod is created, then destroyed, and then you create a new pod altogether. That is not with the containers.
Okay. Okay.
So guys, what you are going to do? So you are going to learn the resources. So let's target some of the resources. So the first resources you should learn, which is namespace. Okay. Second resources you should run pod. Third resources you should learn deployment. So here, what is a pod? Compute unit. Deployment. If you want to deploy multiple pod, use the deployment. After that, in the load balancing, I'll teach you service. Okay. And in the storage, I'll teach you PV, PVC, and stuff like that. So these are the resources which I will cover, and I'll accommodate few more resources. How many resources we have? So look at this yourself. You can count it. These are the 74 resources right now you have in the cluster. Okay. So these are the resources. See that here. Name of the resources, short name, API version of it, that is got deploy. Namespace true and false. What is the namespace true and false? I'll teach you. And this is the for YAML file. This is case sensitive. Okay. So now what to do? So basically there's so many resources. So I'll teach you the one magic formula which you can use it. What exactly that is? So you know the CRUD, right? What is the meaning of CRUD, all of you?
Create, read, update, delete.
Yeah. Remember that, guys. API service is a way that you do the CRUD. Okay, CRUD means you are calling the API service, create, read, update, and delete. So these all are API, okay? And this API is accessible on API server. And how do you call this API server? kubectl command and all. So yeah, these are the create, read, update, delete. So these are the create, read, update, and delete. These are the four method. Now I will ask kubectl, hey kubectl, can you please tell me how do I create, read, update, and delete? So just enter it, and you see here basic commands, intermediate commands, deploy commands. This will work with the deployments. Cluster management command, administration command, debugging commands, okay, advanced commands, setting commands, and some of the stuff. So half of the commands I'll cover in this session. You'll get it. So how do you create it? So create. So everything you can do through two ways, command line and YAML file. So you want to use create command. If you are use YAML file, create -f. How do we read it? So there is a command which is called get. One more command which we have a describe here. So here get describe. Sorry, command YAML. So here get describe, and here you have YAML file. Same way, link mistake actually. Here you have to use -f YAML, and here -f YAML, same way, YAML file. You can write a JSON file also, that we don't practice. YAML is easier. How do you update it? So there's one command edit, and there's one more command which is called apply here. So here command edit YAML file apply -f. Okay. How do you do the delete? Again, you have a command, you have a YAML file. Command, you have delete and YAML file if you have. So anything in Kubernetes you can do through command line or YAML file. Pattern very simple. So these are the stuff. So which is the first resources? Namespace. Now the question is, what is a namespace? Let's understand this. So let's visualize this through some images quickly. So MS Paint. Now just imagine this is your cluster. Okay. Powered by multiple worker, one worker, two worker, three worker. So Kubernetes will make you this all three capacity of three worker, let's say 5 GB, 5 GB, 5 GB altogether 15 GB. Okay, so 15 GB total cluster size is. Now there is a two teams. Understand this way. There's only one cluster. Whole organizations will use it. So there's one product team. There's another product team. They deploy the pods. So here, here, here. They also other team also deploy the pod here, here, here. Remember that clustered means combining all the capacity. Though the physical workers are there separate, but Kubernetes makes the single compute unit. Okay, uh, logically. So 15 GB you have a capacity. Now there is one incident happened. What has happened? This team has deleted this pod by mistake. Now this team is having problem with that. They are started fighting it. Second incident, what is happening? This team member is having certain bugs in the pod containers, and because of that, this is running here, this is running here, this is running here. So causing bugs will consume lots of CPU and RAM, and because of that, this pod is not running. Now other team is blaming on the other team. So this kind of firefighting will happen for the resources like CPU, RAM, and storage, or some misuse of access may happen, accident may happen. So one cluster is for entire organizations. How do we separate it out? How do we distribute the one cluster with multiple teams so they should not fight with each other for the resources and access? That is where what we are doing. We are saying, hey, convert into the namespace. So divide the cluster not based on the vertical, like you take one worker, I'll take one worker. No, this cannot be done. So this one distributed. That means I will create one cluster into multiple namespace, and one namespace I'll assign to team one, another namespace I'll assign to team two, and I will set the limit 5 GB. I'll set the limit 5 GB. So that means no matter how many pods you are running, you cannot consume the more than 5 GB. Now this I have given access to this I have given to access to this. They cannot do beyond this namespace. So what is a namespace? So namespace is a way to distribute the resources and access with the multiple teams so they can work without impacting others. Are you understanding? It's a logical separation, not a physical separation. That means we are not dividing the worker, rather than we are dividing the logically. Are you
Rajesh,
understanding all of it?
what is the exact meaning of like of clusters? Clusters means
Me-
the combination of worker nodes or
Cluster,
what?
cluster means you have hundreds of worker node and combining into one logical unit, that is called cluster. Okay, so
And
this is
what
the
is
one.
control panel? Control panel is a master node or what?
Master node which manage your clusters, which is making the all the worker as a one compute unit.
Okay.
Okay, so now this is a namespace. So guys, uh, in the Kubernetes there are few namespace got created. Let me show you here. in advance, kubectl get ns. These are the namespace. So here, if you see that they are running all the Kubernetes related pods which required to run it to maintain the cluster. So they are running in the kubesystem namespace here. So these are the pods which is running in the kubesystem namespace. So there is a other namespace also. This is for the public, means common namespace. This is created for the node administrator, and anyone who's not having any namespace, he will be part of this namespace. So pod can be created in the namespace only. If you see that these are the pods created in namespace only. You cannot create a cluster because we divide the name cluster in the multiple namespace. Okay, so now if you look at this on the same line, so here if you see that there are certain resources which we have a namespace true. Certain resources you have a, see, look at the pod, it says true, and here if you look at the nodes it is false. Why? So if you see that picture, this pod is created inside a namespace, so that's a true. But this worker is not available inside a namespace. No, worker is for the entire cluster. Each worker is for the entire cluster, not only for namespace. So that is where the node says false. So anything which is belong to a cluster, namespace false. Anything belong to the inside the namespace, true. Like that, true false, true false. So now the question is, how do we create a namespace? My own answer, you know that. Create, read, update, delete. You can do through the command line, you can do through YAML also. So let me create a namespace using command line and then you'll understand that. So here, create first, so kubectl create ns Rajesh. And you see here, using command line, I created namespace get ns, and here is a namespace I created and read it. You can use the describe also. Describe ns Rajesh, and this is the detail. Right now, this namespace which I created, I did not assign any quotas for the CPU and RAM, but you can do that. So this is the namespace I created and read it and describe it. Now can I edit it? So yes, you can edit it. So edit here and edit. Now when you are not sure about it, what to edit, slowly you will get into that. Stick to the labels, edit. Every objects which you create in Kubernetes has a labels field. So this is a team dev. Added one labels and you see here edited. Now you can describe and see the labels team dev. And then finally you can delete this. So delete command. So here delete ns Rajesh. And this is the whole CRUD which I followed for the namespace. Did you understand that, all of you? All of you?
If you edit it, the namespace, and if it something goes wrong, will the whole pod will have the issue, or like only your pod will have the
No,
issue?
it will not be edited. If something goes wrong, it will not be edited. It will be discarded, the changes. YAML.
Okay, so you are allowed to edit only the correct things, not the wrong ones. Yeah.
Yeah, wrong. No. So over the period of time, you'll get a habit of this. So guys, this is the first resources which I created. Follow this rule, namespace. So next one is a pod. How do we create a pod? So pod I'm going to create through the YAML file. Okay. So let me get a YAML file. Go to my website. Type pod example. You can copy it from the Google also, but mine will be a little easier in terms of learning. So this is the one pod. YAML file. This is YAML file. What you want? Pod. What is the version? API v1. What is the name of the pod? I'll just name it Rajesh. Okay. What is labeled with? This one. Pod will have a containers S. One container. This is my image nginx running on port. If you want two containers, you can put it up like that, change the image, port number and stop. So like that. So this is the one containers, one pod, that is sufficient. Now can I create? So here
What is the
I'm
name? What is the name you're changing on the container, Rajesh? If you want to, just like the spec.
spec. Yeah, here
Okay, changing
two
the DevOps
containers
tool.
if two
Yeah.
containers you want. So here like this.
Okay. And the name also you're changing. DevOps School 1, DevOps School.
Yeah, you should change this name also.
Okay.
Container. Others
Yeah.
will not take. It will warning, give you
Well,
warning.
in in a single pod, how many containers we are running?
As
Good
many
question.
you want to run it, depends on you. But don't run a similar container.
Yeah, yeah.
Okay.
YAML
So
is the
now
only option to create pod, Rajesh. Is there any other option we have? I mean, any other
I
method?
told you command
Okay.
YAML. JSON also you can use it.
Okay.
So here I'm doing through YAML this time. So vi pod.yaml, enter this one, save it. Now pod can be deployed in the namespace. So if I run this one, create -f, same pattern I'm running. I'm not running anything against anything off. Say create f, get f, edit f, delete f, apply f. Okay. So remember that. So now this is the pod.yaml. Now if I run this command, it will deploy in the default namespace. And if I run this command -n Rajesh, it will deploy in the Rajesh namespace. Rajesh namespace is not available, so I'll create it one new. Create ns Rajesh. Everything resources you can create through YAML or command line. Done. So I deploy the same pod in the two different namespace. If I deploy again, so it will say, hey, that pod is already deployed. So to the namespace, name of the pod is unique. Okay. kubectl get pods. So if I run this command, it will be from the default. If I want all, see that here Rajesh from Rajesh and here Rajesh from default. Two pod got deployed. So if you specify the namespace for every commands, you will work with a different namespace also. So I deploy this. After this, I'm going to edit. So how do I edit? So here edit command I showed you, but here this time pod.yaml and modify what you want to modify. So let's add it some labels, team, DevOps, and apply. So kubectl apply -f. I'm modifying this default one -f pod.yaml and done. You can describe this, describe pod, and then pod. What is this? Pod Rajesh in the default. Look at this. Here you have this one. There are few more combinations are there. You should try get pods IP address and all you want. Get pods -o wide and many combinations are there. So this is the IP address of the pod in this worker node it's running. So guys, I did create this time through YAML file, okay, and then finally deleting it. So kubectl delete -f
How do you
pod.yaml.
know it is running or not, Rajesh, before you deleting it?
Here it is.
Okay. And you cannot stop it and you cannot restart it, right? As soon as it
No,
keep on running
no,
for lifetime. Yeah.
no. Yeah. Now all the pods I've deleted from the both the namespace. Nothing is there. So guys, you do create a pod using this CRUD. Are you comfortable now, this formula, which you can apply on all the resources?
Yeah, Rajesh, one question. So pod creation, deletion, fine. But if you want to define the size, let's say resources, so here we have to define or some other way.
No, in the pod spec only, if you want the pod to define, limit the CPU and memory, you can
Yeah,
define in the pod spec only. So here only, lots of field will be there. For example, now you want to know all the fields. Let me show you. So
yeah,
qctl, there's one command, explain what pod, which one spec, remember that. Pod.spec.containers. So pod.spec and explain, spelling mistake.
yeah. Okay.
So here, these many fields you have, so many fields actually. That's the reason this is a very simple program, but it can get complicated. So here you can define a lot of things. Now say you want to define the CPU. So let's check it out. Spec containers, containers here, spec containers, enter. And here you again so many things. So how do you define? So grep CPU, search for it, note there, spec grep CPU, not there, containers, and here go inside that. Let me find out that field for this. Arguments, commands, environment, port. I need to refer the Google, just a second. So
Okay.
pod containers CPU. So it's a have so many fields actually. Okay, so you have to check this out. Spec containers resources. So now dot resources, like this you'll learn actually. So dot, and here request, dot request, and then see here now many things has come. So resources, sorry, resource limits.
Limit. Yeah.
Yeah, limits. So limits, here it is. So like this you will understand and do that stuff. See here. Okay, so like this you will understand this way. Okay, so now this is the pod.
Uh,
Now
Rajesh, sorry. Here they have mentioned 1 and point 0.5. So there is difference. So system and user, something like that here they wanted to tell us, or
no,
CPU
so here
one.
they're
Yeah.
saying, hey, here you are saying this pod containers can request 0.5 CPU, and limit is maximum it can be 1 CPU, not more than that. So you should request for this much, but maximum if it is required, you can go up to this one. Got it?
Mhm.
So like that.
Okay, but
Okay,
but
so now
sorry for asking. But if you want to go beyond 4 CPU, so is it possible or not here possible? So
don't set, automatically it
okay.
will go up to the limit of system worker.
But in that case, auto scaling should be on. Then in that case, that parameter has to be on auto scaling, something like that. The
Auto
matlab,
scaling is
it
different.
okay.
Auto scaling is different. Right now, I am
Hmm.
saying creating a EC2 instance. ASG is a different services, right?
Okay.
In
Hmm.
AWS. Yeah, same way. Okay, so now this is the pod. Now, once you have a pod, how do we use it? So that is where you have to work with this commands, kubectl, enter these commands. Where is that? Here. So if you know the Docker, it will be easy for you. So describe, I already discussed about, I showed you. So logs, attach, exec, port forward, proxy is not needed, auth, debug is not needed. So these are the commands which you can get it. So here, let me create one more pod this time. So kubectl apply -f pod.yaml. From now onwards, I'm working in the default namespace, mind it, because -n and all, I don't want to specify. So kubectl get pods. Now here get pods. -o wide. This is the pod IP address. I can access this pod IP address from anywhere in the cluster, anywhere in the cluster. You see, welcome to DevOps School version 1. So I'm able to access one time, two times. Now, how do I see the logs of the containers? Not the pod, containers. Pod is a logical unit. It is logical unit. It is logical unit. You cannot go inside a pod. Remember that. So kubectl logs. What pod? Rajesh pod. Because I'm in default, no need to specify the namespace. See, two times I hit, two times logs. So this is the way you can see that. You want to attach to this the session. So here attach, and where are you? You basically become a nginx. If you remember my session on Docker, attach will become PID1. So basically you are a container, you are on container. You want to see that? So here open up a new console, Ubuntu, and hit this. And you see here, enter, see, 1, 2, your PID1 of the container. So remember that. If you want to, next command, if you want to run some commands inside a container, you can use exec commands. How? Let me show you. So kubectl exec Rajesh container ls. So this command is running in the container of pod Rajesh. You want to go inside that? I hope you remember -it option, and then Rajesh pod number, pod name, bin bash. Where are you? You are inside a container of which Rajesh containers at Nginx. So Docker, it'll help you. Do you want to port forward the pod? So pod, the IP address is not accessible. So exit. So here get pods -o wide. This IP address is not accessible from outside, but worker IP address is accessible. So you can do the port forwarding. How? I don't remember the command, so I'll just use the help. Mind it, guys. This whatever I'm using, you can use a help for many things. So here port forward -h. Remember this h is magical commands. You should always use it. I'm copying it, and here pod name is Rajesh, and container I know that is running on 80 port, and this is the external port. So I'm forwarding default namespace, so not providing it. So here clear the screen, enter. Now port forwarding is happening. You can access the IP address of node, which I think I need to get it from here, any node, and the port number 8888 where I'm forwarding. So 8888, enter. See here. So port forwarding at the node port and so on. Control C, it will not work now. So this is the way you can port forward. Do you want to copy certain files in the container of that particular pod? So there's one file which is pod.yaml. I'm copying in the temp location. So kubectl exec Rajesh pod and ls tmp. Enter. See, nothing is there. So kubectl cp pod.yaml Rajesh tmp. I'm copying inside a container of Rajesh, and now you see it's got copied. You can do the reverse also from the container to the host machine. So guys, this is the way, these are the commands you can use it to work with pod. Are you understanding, all of you?
The curl command is to access. Right.
Yeah, tell me.
The curl command is to access the part, right? I mean, the namespace.
IP address. Curl is basically to it's for HTTP, an API call. So basically, I cannot. I don't have a browser inside a cluster, so you can use curl for quick response from the IP address of the pod containers.
So once you do this, then what are the things you can do after the curl command? Like you can run any command after that.
No. Curl is a browser, just like to check whether accessible or not. Don't
Okay.
take it seriously. Yeah, it's just like a, we don't have a browser inside it, so curl just to check what is the response is coming.
Okay. Okay. And the logs we can access and check it, like whether we have the
Yeah,
response.
yeah. Okay. So guys, this is the way you do it. So now you wanted namespace, we created through command. We wanted pod, we created through YAML file and the work with the commands, all this thing. So now next one is deployment. So any question before that, all of you?
The troubleshooting the auth and the CP that we need to do
Yeah.
it, right?
So CP I showed you. Auth means what? So you can check your permission whether you have a permission or not. Right now you are admin, so you have every permission. But if you are a normal user, you can check your permissions. So for example, kubectl auth create pod. Can you? Yes. Oh, so there's something missing. -h. And here can I missing. Auth can I option and create -h. Remember that it's a magical command. Okay. So create pod. Can I create pod? Yes. Can I create NS? Yes. Because you can check your permissions whether you are allowed to do or not. By default, right now is your admin, so everything is coming yes. Got it,
Yeah, Raj.
all of you? Okay. So now next services which we have is deployment. So what is deployments? So guys, here I created one pod, but in reality, you will have to create multiple pod. So how do you do that? Deployment. So deployment have a multiple feature. What are the feature? Replications. One feature. Second feature is what? Controller. Third feature is versioning. Fourth feature is what? Rollout. And fifth feature is rollback. Okay. So what is this? All this feature? Replication means through the deployment API resources, you can replicate one to many pods actually. Many means thousands of pods within a seconds. Many to one also you can do that, reverse way also you can do that. Many to one. That means whatever the number of pod you want using deployment, you can use it. Many to one also. Now what is a controller? So controller means, let's say you said, hey, I want 100 containers, 100 pods. It will be 100, not 99, not 101. So Kubernetes will make sure that 100 is equal to 100. Now versioning means you deploy the pod image with a v1 first time. Next time you deploy the upgrade the image, it will become a v2. So this, and then after some day you deploy v3. After some day you'll become a v4. So these are the image will be keep changing for that particular pod. So whatever that you are changing the information of the deployment, this automatically will be version in the Kubernetes. Yes, it's like a Git. These files will be automatically versioned, and if you want to roll back to this and this and this, you can go back. So here rollout means v1 to v2, that strategy. v2, that's called rollout. Rollback means v2 v1 rollback to v2 to v1. Simple. Version 1. Image will change. So that means you can roll out all the pods without a single second of downtime. You can roll back again without a single second of downtime. Automated versioning is there. Whatever the you changes in the deployment automatically there. Controller feature is there. Application feature is there. So all these 5 features you have in the deployments. Are you understanding, all of you?
Can you explain this controller one more time, Rajesh? This controller
I'll
is
show you that. I'll show you the demo. You'll understand better way.
Yeah.
okay.
Rajesh, one more question. So let's say pod comes under the namespace and namespace come under the cluster. So if my cluster goes down, so is there any resiliency here? Entire cluster?
So cluster will go down. So there are lots of ways to make it highly available. First of all, cluster is not running on the one worker. You'll have hundreds
Yeah.
of worker sub powered by. So one is go down, no problem. Whatever the pod it was running in the this node, Kubernetes will replace in the other nodes. That's the one thing. Master, one master is a dangerous. So typically we set up a 3 master for HA. One master is not working, no problem. Second master will take care of the rest of the things. So these are the two ways you can make it a resilient actually.
But we have to configure, right? It is not automated feature provided
No,
by
no,
cloud
no,
provider.
no, no. Wait,
Oh,
wait, wait, wait. Cloud
uh,
provider has provided this feature because we are paying for it. But if you set up manually, then you have to do manually.
okay, 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 fine.
Yeah.
By
If
default
I
is
go for
not on here. Mhm.
if I go and configure the cluster on AWS using EKS, they'll give me the three masters and with HA capability. And but I'll have to pay for it.
Okay, okay, yeah, got it. Yeah,
Yeah.
yeah.
So guys, these are the features what you have in the deployments. So any other questions, guys?
If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.